Welcome to this explainer. Look, if you're gearing up for the Cambridge IGCSE Additional Mathematics 0606 exam, you will already know the syllabus is, well, it's pretty demanding. But what if I told you that you shouldn't just study for this like a traditional test? What if, instead, you approach it like a really complex video game just waiting to be decoded? Today, we're going to look at the exam through the eyes of a game designer. We're breaking down the mechanics, the hidden traps, and, yeah, the cheat codes to maximize your score. And we're zeroing in on one specific, notoriously tricky boss level of the syllabus, using correct vector notation.
So, why exactly is vector notation the most misunderstood area of this entire syllabus? Seriously, you might think vectors are relatively straightforward, right? I mean, it's just magnitude and direction. But guys, the principal examiner reports tell a totally different story. Year after year, examiners point out that using correct vector notation is this massive stumbling block, where otherwise brilliant students just consistently drop crucial marks. And here's the kicker. They don't lose these marks because they can't do the math. No, they lose them because they don't understand the rules of the game Cambridge is actually playing. They trip up on what look like straightforward questions because they totally miss the specific requirements of multi-stage analysis. Our goal right now is to fix that and show you exactly what examiners are looking for.
All right, let's jump straight into level 1, the vector notation trap. Before we can start racking up points, we absolutely have to know exactly where the hidden landmines are placed. And honestly, these aren't complex mathematical failures, they're procedural ones. So here are the top 3 mistakes pulled directly from the examiner reports that will literally instantly bleed your points. First up, using the wrong approach for the specific context. Students so often see a vector question, grab the very first formula they remember, and just blindly apply it without actually reading the context of the problem. Huge mistake. Second, formatting and presentation failures. In vectors, notation is literally everything. An underlined letter, a bold font, a little arrow over the top. Forgetting these strict formatting conventions basically tells the examiner you aren't fluent in the mathematical language. And third, answers lacking the required specificity. If the question asks for a vector in terms of a very specific context, handing over a generic answer just won't cut it. To avoid falling into these traps, try using a visual story method. It's a great memory hack to encode these notation concepts in your mind. Just picture the notation as the essential equipment your character needs to survive that specific level.
Moving right along to level 2, core conceptual principles. This is where we transition from just avoiding mistakes to actually understanding the engine of the exam. We need to talk about the difference between superficial breadth and analytical depth. You see, the theoretical architecture of correct vector notation totally relies on precise definitions and causal relationships. The Cambridge assessment framework strictly prioritizes analytical depth. They don't just want to see that you've memorized a broad range of formulas. That's superficial breadth. No, they want to see logical, structured reasoning. They're targeting very distinct cognitive domains here. Knowledge, application, and deep analysis. You literally have to prove you understand the mechanics running under the hood of the problem.
And that depth builds directly into our next absolutely crucial strategy, mastering the cross-topic connection. Top-performing students, they never view vector notation in isolation. The syllabus explicitly emphasizes that the best candidates exhibit a connected conceptual understanding that transfers to totally unfamiliar contexts. Think about it. When you can link vector geometry to trigonometry or calculus within the exact same paper, you're demonstrating true mastery. In fact, principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. It shows you aren't just playing one level, you see the entire game map.
Let's level up again. Here is level 3, the procedural framework.
All right, this right here is your precise step-by-step game plan for exam day. It's how you secure maximum points and build professional skills. Honestly, just memorize this sequence. When tackling vector notation questions, systematic processing is non-negotiable. Step 1, deconstruct the question so you can identify the key elements. Step 2, extract all the relevant data. Step 3, select the appropriate analytical framework or principles. Step 4, execute your analysis with crystal clear working and notation. And finally, Step 5, present your verified results using the absolutely correct terminology and formatting. The presentation of information in this topic follows incredibly strict conventions. We're talking proper headings, appropriate formats, and clear annotations. These are not optional, guys. They are literally the keys to unlocking those points.
Now for my absolute favorite part. Level 4, securing every method mark.
Listen up, because this is the ultimate safety net for any Cambridge Additional Math student facing multi-stage analysis. If there's an actual cheat code in this game, this is it. I want you to burn this definition into your brain right now.
the method mark strategy. In complex vector problems, marks are awarded for demonstrating the correct logical process and analytical steps, regardless of the final numerical answer. Let me repeat that just so it really sinks in. Marks are awarded for the process itself. This means that if you execute your analytical steps perfectly, but, maybe you drop a negative sign right at the very end and get the final number wrong, you still get rewarded for your logic.
And this isn't just me saying this. This crucial point comes directly from an examiner alert. Quote, even if your final answer is wrong, method marks can save you. Students lose marks by not showing working. End quote. This is exactly why that procedural framework we just discussed is so vital. When you execute your analysis with clear working, you are documenting your logic for the examiner. If you try to be a hero and do the math in your head and then just write down a wrong final answer, you score a 0. But if you show your structured reasoning and just make a tiny, silly arithmetic error along the way, those method marks will literally save your grade.
All right, the final boss, level 5, the high score.
So how do we move beyond just getting the math right to actually demonstrating the absolute highest level of evaluative insight? While top-scoring candidates do way more than just calculate, they evaluate. If a complex vector problem requires comparative analysis, they identified both comparative similarities and differences, using clear comparative connectives. They question the underlying assumptions made in the problem. They justify every single mathematical decision with solid evidence, and they can evaluate the limitations of the data or even suggest alternative interpretations of the results. This level of critical analysis, showing that you understand not just how a vector behaves, but exactly why it behaves that way under given assumptions, is what extracts every single available mark from the examiner.
So I'll leave you with this final, kind of provocative thought to consider before you tackle your next past paper practice. Are you just trying to solve the problem, or are you proving your methodology? The 0606 exam isn't just a test of whether you can find the right number. It's an amazing opportunity to prove to the examiner that you are a precise, logical thinker who truly commands the language of mathematics. You gotta shift your mindset here. Stop just trying to beat the problem and start designing the perfect, structured solution. Keep practicing those past papers with this framework in mind, and I promise you'll completely change the way you play the game. Thanks so much for joining me on this explainer, and keep learning.